Alright, so we're talking about the concepts again, 4.5, section 4.5, last video of our section, talking about logarithms and exponents. Concepts of 4.5, we're talking about solving exponential equations here, and we're also talking about solving logarithmic equations. If I've got a logarithmic equation like this, here's my log equation in the rectangle here. What I do is I first combine the logs. So I start with a log base 3 plus log of x minus 2 equals log of x. All I'm doing is rewriting this equation. What I'm going to do is use my properties of logs to say, we're going to go back a little bit, log of AB equals log of A plus log of B. And the other rule that we're going to use here is log of A over B equals log of A minus log of B. So we're going to use these properties moving from the right to the left because we've got a whole bunch of stuff that's kind of separated. This equation in blue has been expanded already. We need to kind of combine it, contract it a little bit. So we're going to move from the right to the left. So if we've got logs that have the same base and they're added together, we're going to use them and combine them into a product, into the log of a product. And if we've got things that are subtracted, that becomes the stuff that's inside the log over here that's being subtracted, that becomes our quotient, or sorry, our denominator. So let's combine what's in blue over here using the rules in black. I'm going to say that, well, let's say log of 3 plus log of x minus 2 minus log of x. All we're doing is moving that log of x over to the other side by subtracting both sides, subtracting that log of x on both sides. Now from here in the blue we can use these rules moving from right to left. So let's combine all these. Log of all of this stuff, 3 times x minus 2 divided by x equals 0. And all we did was combine all three of these logs together. Instead of expanding this to get this, we've compressed or contracted this to get this. Now we're going to use the idea of kind of our definition of log. If log base b of x equals y, then, and it's equivalent to, b to the yth power equals x. We're going to use that green rule now to change this log. Oh, by the way, it's base 10 because it's not written here. We understand that it's a 10. So log base 10 of all this stuff equals 0 is the same as using the green rule to say 10 to the 0th power equals 3 times x minus 2 all over x. So we're just using our green rule here to apply here, and now we're going to change the log equation into an exponential equation and solve that. So let's start with 10 to the 0 equals 1 equals, let's expand this, 3x minus 6 over x. From here we can multiply by x to get rid of our denominator. X equals 3x minus 6, and we just solve that. Now we subtract x, we get 0 equals 2x minus 6. I'm going to extend my page here a little bit. I'm going to add 6 to the right side, add 6 to the left side, and I get 6 equals 2x. Divide by 2, x equals 3, and I'm done. So let's go back up here and kind of review our rules. First, combine the logs to get the equivalent equation. A went all the way down to, let's see, about here. So question B says write each side in exponential form to get the equivalent equation. Right here is our question B. That's our question B. There's our equivalent equation. 10 to the 0 power equals 3 times x minus 2 over x, or this one here. Either one of these would be okay. And step C was basically we just solve. Step C was all the rest of the stuff. We're taking this and solving to get x equals 3, and that's our question 3. X equals 3, and we're done. So equivalent equations, we're going to walk through equivalent equations. When we're given a log equation, we can solve it by combining the logs and converting using our green rule, this rule over here that says log base b equals of x equals y is the same as b to the y equals x. Same idea applies for solving an exponential equation. If we've got an exponent, we isolate this exponent or exponential term by dividing or subtracting away everything that's kind of attached to it, and then taking the log of each side. In this case, it's the natural log, and in any other case, it'd probably be the log.